My name is Mats Lanér. I'm the Director of Engineering for ECS, so responsible for all things ECS and related. With me, I have Alexander.
Hey folks, I'm Alex. I'm a product manager for Amazon ECS, focusing on Fargate.
And we also have our distinguished guest.
Yeah, hi, Ruben, Quantitative Technologies at QRT. Nice to meet you.
Cool. So today we're going to talk a little bit about what Amazon ECS is, what it works. This is a 300 session, so we assume that you know the basics of ECS since you chose to join us. Then I'm going to talk about capacity provisioning with ECS, how you get the compute you need to actually run your applications. After that, Alexander will take over and talk about security and compliance aspects of running your applications on ECS and how we help you there, and also cost optimization, what we do to make it cheaper for you to run your applications. And then perhaps most interestingly, we'll have Ruben talk about the journey that Cube Research and Technologies have been on ECS, going from a reasonable scale application to a very large scale workload on ECS and Fargate, which has been super exciting to see. So what is ECS? The simplest way of thinking about it is that ECS is a container orchestrator built for use on AWS, where the guiding principle is that we take on as much of the operational chores as possible so that you can focus on your application instead. There's no control plane to manage because we take care of that. If you use Fargate, there's no compute to manage because we take care of things like that. So looking at ECS, there are 4 pillars we think about for how ECS works and what we build it for. So the first one is that it's to launch containers at scale. It doesn't matter if your workload requires one task and runs at a fraction of a TPS, or if it's a very large-scale application with tens of thousands of tasks running at the hundreds of thousands of TPS. ECS is there to support you on that whole journey, giving you a consistent operating model regardless of what your scale is. Second is that you only pay for what you use. And what that means is that there's no charge for using ECS itself. What you do pay for is the resources that we provision for you. So if you launch EC2 instances, well, you pay for the EC2 instances, EBS volumes, load balancers, and things like that. But you only pay for the things that you actually need to run your application. If you're using Fargate, for example, if you're not running a task, there's no charge for Fargate, right? You only charge while you run Fargate tasks. Going back to what I mentioned earlier, we're all about improving speed and agility for you all. We want you to be able to focus on your application, be able to reach scale and production with your application as fast as possible, and not have to fiddle with a bunch of infrastructure mechanisms. That doesn't mean that we lock you down so that you can't do advanced scenarios, but the default experience is to get you up and running with AWS best practices, and then when your use case requires it, you can dig into more advanced capabilities and take advantage of those. And finally, as I mentioned a little bit earlier, we embody AWS security and operational best practices in AWS. We try to set you up for success. Part of that is that if you use things like Fargate, you don't have to worry about how correctly configure an instance to run your workload. We take care of all of that. With Fargate, you get task isolation. So every task you run runs in its own EC2 instance. And in EC2 instance that is never reused. It's only used for the life cycle of the task, and then it's recycled. And to give a little bit of context about ECS and how ECS is growing. As of about 2 months ago, customers launch about 3 billion tasks on ECS every week. That's across all of our regions. And looking at new customers who come to AWS start running new workloads and choose to use containers to run those workloads, we see about 65% of those customers choose to use ECS, and the vast majority of them choose to use Fargate with ECS because it just makes their life easier. Additionally, a lot of Amazon also runs on ECS. Both AWS services and Amazon.com services run on ECS. And one specific example that we can share here is that during Prime Day this past summer, the team supporting Prime Day launched about 18 million tasks on Fargate every day during Prime Day, which doesn't quite include everything they launched leading up to Prime Day, but still. So it's an indication of Fargate and ECS is ready to support the biggest workloads out there. So why do customers choose to use ECS and trust ECS to run their applications? Part of it is simplicity. Not simplicity in the sense that ECS is limited and only gives you a limited set of capabilities, but simple because it simplifies operations for customers. As I've said a few times now, we really want to focus our effort to help you focus on your application. We'll take care of the other operational chores for you. Other thing is secure, obviously. We all want that. So we make use of AWS security best practices. We set you up for success with that from the beginning without you having to do anything explicit about it. And finally, efficiency. So we're very focused on driving high utilization for you so that you can run your application at scale with high availability at the lowest possible cost to you. And we do that in a number of ways. So for example, with Fargate, you tell us that you need a 2 vCPU task with 8 gigs of memory. Well, that's what we provision for you, and that's what you pay for. If there's any overhead on our end on that, that's our problem to solve, not your problem. You tell us you want 2 vCPUs, we give you 2 vCPUs. All kinds of things like that we do, including scaling up when you need to scale up, scale down when you need to scale down, things like that that will make it easier and lower cost for you to operate your applications. So digging in a little bit into capacity provisioning. So how do you get the compute you need to actually run your application tasks? I'm not going to go through everything in this slide, but I do want to give the context of AWS provides a wide range of compute options, right? And at the end of the day, most of it relies on EC2 in one way or another. The exception would be if you use ECS anywhere and you run on premises, in which case you're on the hook for providing the actual compute. But you can use ECS to run across all of these options. You get a consistent operating model. But we also see that the vast majority of our customers use either EC2 or they use Fargate. So I'll dig in a little bit to what the trade-offs and benefits are between using Fargate and EC2. So Fargate, which many of you are probably familiar with, provides a fully managed data plane for you. We abstract away the compute to the point where the only thing you need to think about is the amount of vCPUs and the amount of memory that you need. There are a few other things that you can control as well. You can request more storage and things like that. But centrally, it's CPU and memory that you think about. So we take care of everything else, right? If you need to launch 2 tasks, we'll provide a compute that can run 2 tasks. If you need to run 500 tasks, we'll provide that compute. We take care of providing workload isolation by design in Fargate. As I mentioned earlier, every task runs on a separate EC2 instance. That EC2 instance is provisioned for that task. When the task stops, we throw away the EC2 instance. So every time you launch a task, you know that I'm running on fresh compute. There's nothing left from previous tasks or anything like that. There can be no task crosstalk or anything like that, which for many customers is a key feature in Fargate. And I mentioned already about how you only pay for Fargate tasks when they're running, right? As soon as the Fargate task stops, there's no more charge for it. So you get a lot of benefits with Fargate, but you also give up control of things. So if you choose to use Amazon EC2 as your compute, you get a lot of control. You get to choose exactly which EC2 instance types and sizes you use for your application. Whereas with Fargate, we use a wide range of instance types and sizes for your tasks. Depending on region, depending on availability zone, you may see us use, say, an M8i for a task versus an M6i, depending on availability. We always focus on being able to launch customer tasks, prioritizing that over consistency in the underlying compute, which is an important aspect of Fargate. For EC2, you control all of that. But that comes with a cost, because now you're also on the hook for providing the AMI that we use for the EC2 instance. So you have to make sure that that AMI and that instance is correctly and securely configured. You need to make sure that you patch your instances. That's on you to take care of. But on the other hand, you do get to take advantage of all the EC2 purchasing models. You can use reserved instances, you can use on-demand capacity reservations, instance savings plans, things of that nature. Both Fargate and EC2 supports the compute savings plan, so you do have that option available regardless. So there are a few tensions between using Fargate and EC2. And we've had lots of feedback from customers telling us that, we love Fargate, but we need a little bit more control for our workloads. So in response to that, we launched ECS managed instances about 2 months ago. And what we're trying to do here is strike the right balance between managed compute that we give with Fargate versus giving you all more control over what we use to run your workloads. So a couple of key differences is that with ECS managed instances, we launch EC2 instances in your account. So you will see these EC2 instances, but you have no control over them. You can't take any mutating actions on these instances. Only we can do that for you. But that also means that we control the entire life cycle of these instances. We make sure that we launch them when they're needed because you need more compute capacity to run your applications. We make sure that after roughly 2 weeks, which is very similar to how Fargate operates, we will retire the instance and we will shift your tasks over to a new instance. And we do this so that we can patch your instances and make sure that we always meet patching SLAs. You have control over the instance types. So you can either choose to say, no, AWS, I trust you, pick the most cost-optimized instance types for my application. Or you can say that, no, I know exactly what I need. I need network-optimized Graviton instances for my workload. And you can choose to use that. Or you can say, hey, I want GPUs for my workload. You can get those with ECS managed instances. We have more robust cost optimization in ECS managed instances. So one is that we've rebuilt how we scale up additional compute for you. So we can scale up additional compute faster with ECS managed instances than we can with both Fargate and EC2. But we also implemented cost optimization that continuously looks for idle instances or underutilized instances. And when we find underutilized instances, we will shift tasks over to other instances and then be able to shut down those instances and reducing your costs as a result. And finally, we give you more control. So many of you who are Fargate customers today will know that you can't run privileged containers on Fargate, right? You can't make use of agents that use eBPF, for example. With managed instances, we give you this ability. By default, Nothing runs as privileged, but you can say in your task definition, hey, I have this sidecar container. It needs privileged access because it requires eBPF, and you can do that. So going back to the earlier slide, where does managed instances fit into the picture? So it's right in between Fargate and EC2. You get more capabilities. We still give you a fully managed compute experience, but you need to be more aware of that we actually provision EC2 instances for you, even though we completely manage them on your behalf. So a core concept in ECS is capacity providers. We introduced this back in 2019. Originally, we had the Fargate capacity provider, which is actually two capacity providers, the Fargate On Demand and Fargate Spot. And we introduced the auto-scaling group capacity provider for EC2 use. So with managed instances, we've introduced a new capacity provider that works closely with the whole task cycle in ECS to make sure that you have instances available to you when you need them and only when you need them. So looking at the Fargate capacity provider, as I mentioned before, it's simple, right? You don't have to worry about EC2 instances. You need not worry about configuration, patching, anything like that. When your workload increases and you need more tasks to run your application, we will launch more tasks for you. When your workload decreases, we will scale down those tasks. And all you need to think about, as I mentioned before, is the amount of CPU and the amount of memory that you need. For managed instances, I touched on some of these things already. So this new capacity provider is tightly integrated with the rest of ECS to know when it needs to launch additional EC2 instances and when it should shut down EC2 instances. We launch these instances in your account, but they're fully managed by us. You can see them, but you can't terminate them. You can't take any mutating actions on them. And we control everything about the management of these instances. So for example, we provide the AMI used for these instances. You cannot control that. We use Bottlerocket as our container operating system because we think it's the right Linux OS to use for container workloads. We make sure it's configured correctly, and as I mentioned, we run for about 2 weeks, and then we replace instances, shifting your workloads transparently. One thing that you get with ECS managed instances is that you get to use EC2 event windows. So if you want to control when we replace your instances, you can create EC2 event windows and tell us, hey, use this 4-hour time window on Sunday mornings between 1 a.m. and 5 a.m., and we'll make sure that we only initiate operations in that event window. So with these managed instances, you have the option to map the instance type to your workload needs, right? So you can use the default capacity provider, then you don't have to do anything other than just selecting it and trust us to pick the right instance types. And we'll focus on cost when we make those decisions. Obviously, the tasks you run also matter. We try to bin pack as tasks onto multiple tasks on an instance, so we'll take that into consideration as well. But when you want to explore more capabilities, you can use the custom capacity provider, and then you get to use what we call attribute-based instance type selection. So you can define things like, hey, I need a GPU. I need a GPU of this particular type. I need at least this number of vCPUs on the instance. It needed to be network optimized. Any number of attributes like that you can control. So you don't have to pick specific instance types, although you can if you really want to. Instead, focus on the attributes of these instances that map to what you need for your workload. So now we have EC2, we have Fargate, and we have managed instances. So when should you use these? So we strongly recommend that if you're using ECS on EC2 today, you should go take a look at managed instances because we think we can give you a much better experience using managed instances. For Fargate, Fargate is the default in ECS today. It will remain the default because we think that is the best experience for the most customers. That said, if you're on Fargate today and you run into limitations on Fargate, then managed instances is there to support you. So for example, if you need to run a 48 vCPU task, well, Fargate does not support that, but managed instances does. If you want to use a logging sidecar that requires eBPF, well, Fargate does not support that, but managed instances does. If you want to be one of the cool kids and use a GPU workload, well, Fargate does not support that, but managed instances does. So those are the kind of things that you should think about when you want to use managed instances. And with that, I'm going to hand over to Alexander, who's going to talk about security and compliance.
Well, thank you, Matt. Security and compliance. What an exciting topic, right? So let's try to make it more or less painless. When we talk about security, we usually start with looking at the shared responsibility model. And let's take a look at the screens right now. That's the situation with ECS and self-managed EC2. Well, AWS is responsible, of course, for the ECS control plane. It is responsible for all the foundational services, storage, compute, network, and all monitoring, and of course, the global infrastructure, basically regions, local zones, everything that is actually physical. But you have to worry about and secure all your compute capacity. You need to think about how to provision that capacity, how to scale it up and down, how to distribute it across different availability zones. You need to think about instance selection. And more than that, each time you launch an instance, you need to place the right AMI. You need to make sure that it has the right version of the agent. You need to patch it. And of course, you need to keep monitoring all that stuff. On top of that, your application runs. Yet another layer of complexity. So that becomes rather complicated, I would say. That's why with Fargate and now with ECS managed instances, AWS takes on more responsibilities. So you don't need to worry about things that you worried about with self-managed stuff, things like capacity provisioning and EC2 instances, everything that runs on them is fully managed by AWS in different ways. And I'm going to talk about it in a minute. So the key point is that you're still responsible for your application, how the load balancing happens, how the security groups are configured. So you can configure security groups, define firewall rules, and of course, IAM roles. So basically, this is your responsibility. Everything else is AWS. So as you can imagine, that change in this shared responsibility model gives you way more time to focus on what actually matters to your business, on building the application, building the business logic, serving your customers, while AWS takes care of pretty much the infrastructure and configuration. Now, let's take a look at the isolation boundaries, and that's where we have a difference between Fargate and ECS managed instances. As Mats already mentioned, Fargate provides a really strong isolation boundary security model. Each task is launched on a separate EC2 instance hidden in AWS account, and we do not reuse these tasks. So we never place two tasks in the same instance. We never reuse the same instance for two tasks in a row. We always discard it, scrap the memory, scrap the ephemeral storage. So there is absolutely no risk of data cross-contamination. With managed instances, we launch EC2 instances in your accounts. And we do believe it's the best option for you to actually launch multiple tasks. So we take care of bin packing to optimize the infrastructure, to optimize the utilization. So with that approach, we can probably launch more tasks on less compute and really help you reduce your AWS bill. And of course, you have controls there. If you're not OK with launching, say, tasks from different applications on the same instance, you can use different capacity providers. So you have certain controls there. And of course, you can control the size of your instances to pretty much simulate this single task experience. But we will keep reusing, we will keep these instances running for longer after they become idle. For a very short period of time, it is now configurable. You can actually set it up to 1 hour. So we don't just release that capacity. Why? Well, because each next task that is launched on an already running instance launches way faster, like 3 times faster than a task on a brand new instance when we have to spin it up. So you have these controls with managed instances. Let's take a look at the best practices that we use with Fargate, and they're very similar between Fargate and managed instances. Well, except for the isolation point. Task isolation is a key, probably the key feature of Fargate. We do reduce the attack surface. So we don't have access to underlying OS hardware. You don't have access. We don't really have access to that. So we have access only to logs that are important for telemetry, for troubleshooting. But we don't have access, and we don't give you access to underlying hardware. We do run regular patching. And one very important thing that is often overlooked, AWS VPC networking mode. Why it's so important? Well, because now each task gets an individual IP address. And with that, you can use VPC flow logs to understand what's going on with your traffic. You can use security groups to have fine-grained control for each individual task. So you have really full control over your network security. And that's a major thing, something that you cannot achieve with network address translation. If you're running, for example, bridge mode with ECS, EC2, you can't really do that. So it's a really strong and very secure solution that follows pretty much all AWS security best practices. Managed instances. Look at the list of benefits. Fully managed compute. Compliance and patching every 2 weeks. So if you tell me it looks like Fargate that is launches instances in your accounts, you won't be wrong. Technically, this is Fargate that is exposed to your accounts. So you're getting the same experience with a couple of differences. Well, BottleRocket, as Matt mentioned, it's a new OS that is developed by AWS. It's an open source project that we believe is the best way to run containerized workloads. It has a very minimal set of packages required for containerized workloads. We don't have anything extra, resulting in a reduced attack surface. And of course, all the instances that we launch in your accounts, you don't have access to them. You can still see them. Why you still see them? Well, I can give you an example. Imagine if you don't see them, but they already exist and run in your account, and then you have to go and, for example, delete a subnet. What's going to happen? You're going to get a nasty error message saying, hey, you have instances running, so you'd better see them. So you have visibility, but you don't have control. You don't have a way to change them directly using EC2 APIs. Again, everything goes through the ECS API, an added layer of security. And of course, Matt's already talked about event windows. It's a really neat feature. Your EC2 instances have to go through hardware replacement from time to time, et cetera, so you can define these windows. Now you can use the same concept to tell us when you're OK with patching. So it's not going to happen on a random day. It's going to happen in the time interval that you tell us to. Well, compliance. Really short. Fargate and managed instances really help you achieve better compliance faster. Because now you can point to AWS and say, hey, AWS takes care of pretty much everything but my application. And now to achieve compliance, you need to provide a much, much shorter list of evidences that you actually have meet these compliance requirements. Everything else is on AWS. So we have all this list of things that we provide as an evidence that we actually meet the compliance requirements. So we help your workloads achieve compliance faster. And of course, you can find the list of services and scope if you go to that page. It's a really neat website. Pretty much everything you can find there, Amazon ECS will be there. So compliance is a great topic. But now let's chat about something that is very dear to my heart, how to save money running workloads on Amazon ECS. And of course, we're going to talk about cost optimization strategies. 4 things: choosing the right hardware, choosing the purchasing options that work best for your workloads, figuring out how to scale and optimize your workloads, and of course, observing it and making sure that actually all that works to your benefit. Starting with hardware. We have today, we offer as AWS 3 different CPU options: Intel CPUs, AMD, and Graviton. And of course, with Fargate, you have control whether you want to use x86 64 or ARM CPUs, so Gravitons are ARM. So that's your control. But you can't really choose whether your tasks will land on Intel or AMD. And what if your application takes a dependency on AVX 512, for example, instruction sets that work really well on Intel? Or what if your application benefits from a super strong single-core performance of AMD CPUs? Well, that's where managed instances come to play. You can choose the CPU type. You can choose exact instance types that are best for your compute. And guess what? If you run something like tasks that are jobs, time-bound jobs, if you finish your running your workloads faster, you pay less. So it's an excellent way to choose the right CPU for your workload to actually pay less, or just get the latest Graviton generation with just phenomenal price to performance ratio. Switching to purchasing options on demand. That's a default, excellent for spiky workloads, the most expensive. Saving plans. When it comes to predictable workloads, and if you can commit to spending a certain amount of money on AWS over a year or 3 years, you can get significant discounts with that. So if you have predictable workloads, please, please, please use saving plans. It's a very powerful tool that you have in your arsenal, something that you can use. And on top of that, Spot. Spot is a great way to save if you have fault-tolerant applications. 80% savings on compute easily. Well, with the caveat that we can reclaim this capacity at any time. So really for fault-tolerant applications. This is actually something that is not available with managed instances yet. Let's take a look at Fargate and how Fargate helps you optimize costs. So first of all, not really obvious, but you always get 100% utilization. Matt talked about it, but we give you exactly what you asked for. You don't need to reason about bin packing your tasks on that instance and figuring out what happens when the task goes away, what to do with that empty slot on the instance, what else to place there. Another thing that is really important, you can speed up the task launches on Fargate with seekable OCI, lazy loading. The idea is that we get the container and we start it before it's fully loaded. It's an excellent feature. Please, please, please use it. It works better with large images. And of course, we have Compute Optimizer now. It looks at your workloads and says, by the way, you can stop these instances. You're not using them. Or it's better to right-size them. It suggests a better size if you, for example, run them at very low level of CPU usage. It says, go down the size. You don't need that much capacity, saving you money. On managed instances, the situation is slightly different. Remember multiple tasks. There's been packing problem. What do we do with empty slots? Well, now we actively fill them. We look at your entire cluster. We find underutilized instances, and we compact your tasks to achieve better utilization. And we shut down stuff that is idle, which is really powerful, active optimization that goes on all the time. You can tell us, nope, I don't want that. These particular tasks need to run for a long time. I cannot interrupt that. We have this way. And you can actually disable this feature completely, which is handy when you use something like reserved instances and on-demand capacity reservations. You already paid for that hardware. You already paid for that stuff. Like, why do you want to stop these instances? Maybe you want to keep them running all the time so you can launch new tasks faster. So there are different ways to think about it. And of course, since we have multiple tasks on a single instance, now we can use container image caching. So instead of downloading the container image from ECR every time, your tasks can just grab it from that instance immediately. So to wrap up, you need to think about Fargate and managed instances. And again, we believe that Fargate is an excellent choice for the majority of workloads, but managed instances come incredibly handy when you need things like stuff that just does not work on Fargate. eBPF is one example of that. Another one is related to cost. When you have short-lived tasks on Fargate, I'm sorry, it is not efficient. You're spending way too much money because you're paying for the time the image is being downloaded from ECR. Managed instances, as I said, container image caching and the ability to reuse instances for new tasks, it helps you save money. So everything that runs under 2 minutes, I'm confident it's going to be way more cost optimal on managed instances. Please consider that as an option. And of course, if you have your reserved instances or you have instance saving plans, ODCRs, managed instances, is a simple way to use that capacity and again, save money with ECS. Well, with that, we're coming to the most exciting part of this presentation. Ruben, please come on stage and chat about Kubernetes journey. Thank you.
Thank you very much, Alex. Thanks, Matt. Let's wait. OK, we have it. Hello, I hope you're getting the best of the first day of re:Invent. My name is Ruben, and before diving into the journey and to the technical talk, I would like to introduce myself a little bit. The first thing you need to know about me is that I'm Italian, and that's important for one reason. I have a challenge with myself today to try to deliver at least half of the volume of information I can do with my hands by using words. So you're going to let me know if that works at the end of the presentation. And the second element is I would like to talk about my previous life before selling my soul to finance. I was actually a rocket scientist. I have a PhD in applied mathematics, and I was simulating rocket engines. I must admit I don't regret the choice to switch, but sometimes I miss the random explosion in the lab sometimes. What is QRT? After introduction about myself, I would like to talk about QRT. Cube Research and Technologies is a global systematic asset manager. Let's dissect that a little bit in the right order, which means starting from the end. Asset manager means we get money from our investor, and we put it on the market to make more money with it. By systematic, what we mean is the vast majority of our investment strategies are data-driven and automatic. So we have a lot of algorithms which trade on the market on a daily basis and in an automated way. By global means that QRT is operating across the globe and across all the type of assets, equities, futures, crypto, you name it. And what's the mission QRT? Yeah, I already introduced it a little bit, but it's to deliver results for our investor in all market conditions. Easy to understand. When market is bullish and it goes well, we want to do better. And when things are less well, then we try to mitigate that. All right. We're good with the introductions. Now we want to dive into the nerdy talk. When I joined QRT almost 4 years ago, there was already an existing solution in place, and it worked more or less like that. We have researchers. Researchers are basically the bright people which come up with ideas for investment strategies, right? Most of them, especially in recent times, they're used to do their research with Python because of the rich data science ecosystem or scientific computing. So they were used to do their research with Python, and then they had somehow basically pair up with a quantitative developer and basically rewrite their research in another language, compile that artifact, and then deploy it on an existing on-prem infrastructure, sharing resources with other ideas, let's say. I mean, that worked pretty well. I mean, QRT has been a successful enterprise, but when I joined, we were tasked with another task, basically, which was let's try to build something which is natively scalable and cloud native. So what we said is, okay, maybe we can skip the detour. Let's keep what works. Researchers really like to work in Python. Let's keep them working in Python. And then what we decided to do is containerize our Python workloads. Okay, now we have our container, and we had to decide which kind of orchestration system we wanted to use. I guess the fact that I'm on this stage is probably a spoiler, but we ended up using Fargate and ECS. Why? I will try to explain you why we chose Fargate as a capacity provider and ECS as an orchestrator. First of all, at that time, we were a very small team. We were 4 when I joined, and we wanted to focus on the business. The team was not particularly expert in cloud computing, but we had expertise in the financial part and the standard engineering part, so we wanted to focus on our business. Fargate gave us that serverless vision, which made us focus on our core business. We tend to build things within the team, keeping the intellectual impedance at the lowest we can. And again, Fargate really helps you with that. At that time, when we started our endeavor, we didn't know if it would have been successful or not. So we were looking for somebody which could help us start small, but scale if we needed. And if we needed the capacity to keep up with our growth. Last but not least, financial industry is a very regulated industry, so we needed a by default compliant security posture, and the fact that in Fargate everything is isolated, is encrypted, you cannot SSH in your machine. That really played well for us. So these were the design principles of our choice. Now let me try to explain how things work a little bit more in details. Some schematic here, just bear with me a little bit. In our system, we have 2 types of services. One type of service is we call it quant computational unit or compute units, QCUs, that you see here on the bottom of the slide. And then we have another type of service, which is kind of a server that here is marked logical server. We also call it head node. The role of the head node, basically the QCUs cannot talk, and then we have, as you see in the top of the slide, then we have our underlying firm-wise database with all the data. Basically, the QCUs are designed to not talk directly to the database for performance reason. So the role of the head node is twofold. One is to aggregate requests. So imagine one of your units needs, Amazon prices for the stock for the last 10 years, and another one needs it for the last 5 years. Basically, the head node queries the database for just 10 years, and then it does the slicing locally. And the second one, as you can imagine, is caching. We cache some of the requests in memory. I talked about the fact that this is a logical server. Why? Because in reality, our head node deployment is composed by several ECS services. Actually, in the bigger deployments, several hundreds or even several thousands. In this slide, each square is an ECS service. And one particularity of this is that each service has one task, only one task. This is a bit exotic with respect to the best practices AWS recommends. Why we have that? Again, simplicity. If you have two units basically publishing almost the same thing, then you need to decide which one is the right one. We decided to accommodate a little bit of less resiliency for simplicity. So we are just one unit publishing. All right. And another important element here is everything talks data-driven gRPC protocol. So the QCU talks gRPC to the head node, which talks to gRPC to the shards, and the shards talk gRPC with database. The shards here mean that obviously you cannot host the entire data you need in a single service. So basically, the shards split this data based on several criteria to have a distributed deployment. Then, as I told, like the QCUs, then when they finish elaborating what they need to elaborate, they will publish the results of their computation back into our database. Another important element here is that service discovery. In our experience, when we tried other orchestrating systems, we realized that scaling DNS correctly is kind of challenging. So here we decided to use Cloud Map, which is, again, serverless. And we basically, when we deploy the head nodes, we register a DNS entry in Cloud Map, and that's it. It works. Trademark. All right. How did it go? I guess, again, the fact I'm on this stage is probably a spoiler, but it went very well. I would like to promise you, to give you the reality of things, like the scale we are at. Unfortunately, the compliance colleagues, they hide in shadows, so I cannot tell you the exact figures, but we had 100x growth, which means everything and nothing. What I can tell you is that we have right now deployed several tens of thousands of services currently running, where the several tens of thousands is on the higher range of the tens of thousands. That's what I could negotiate, I could tell you. But based on the schematic I just presented, you start facing some challenges when you begin to scale. For example, quotas on the number of services per cluster, number of CPUs per account, et cetera, et cetera. So actually, we had to evolve our deployment. We actually tag team with AWS with a pro-server engagement, and we ended up with an evolution of the architecture I just presented, which is the following one. We already talked about head nodes. We started to put head nodes in dedicated accounts. So we have some accounts for head nodes, some accounts for the QCUs. All these accounts then are within the same VPC, which is stretched across all the accounts. Few caveats here. When you do this, you need to first define the VPC in a single account, and then when you did that, then you can stretch it, which means a couple of things. The most important one is you can register your DNS service discovery only on the accounts where you have created the VPC initially, and which means in our case, we created the VPC in the head nodes accounts because the head nodes are the thing we want to discover, the QCUs want to discover. And then you stretch it around. If you want to use API-based, so not DNS query-based, but API-based service discovery, that works across the VPC without any problem. Second important element, and this is really the secret sauce to become a successful asset manager, like systematic asset manager, is the naming system for the clusters. As you can see here, we're using flowers. It's really, really the secret sauce for our deployment. I recommend you to do that. It's great. But it's fun. All right. Let's make a little pause. A lot of diagrams and schematic. We grew from few services in a single account, single cluster, single account, multi-cluster, which I didn't show, and now we are multi-account, multi-cluster. You can realize now that this is it becomes to be challenging to control. So you're really required to have the right observability posture. You really want your system to ping you instead of you polling the system. That's much more scalable. When you approach observability, at least in our experience with ECS, you have several options. The one which is most documented is, you spin up a sidecar on your services and with Firelands, and then you scrape your telemetry, for example. Still within the tag team with AWS in the pro-server engagement, we decided to go with a different way, which is a little bit more exotic, but it works for us, and I will present that to you. Again, single VPC, we already talked, single VPC, multiple accounts, some for head nodes, some for QCUs. Those accounts, they basically publish their logs in a serverless way using CloudWatch, and they also publish the metrics, if you turn on Container Insights, in a serverless way into CloudWatch metrics, right? Each account does that. What we did is connect what is called log subscriptions and metric streams. Those are basically some, again, serverless mechanisms which react when a new log appears in CloudWatch in whichever account, or when a new metric appears in whichever account. They react. You can connect them to Firehose, Kinesis, and to a Lambda. And what we do, we use those which are in a single account, and we use those to send our telemetry to our third-party observability vendor. That's for infrastructure-related telemetry. For what concerns your application telemetry, what we did was deploying an OpenTelemetry collector within the VPC we just discussed, spanning across accounts in a dedicated cluster. And this OpenTelemetry collector has been configured to auto-scale. What's a bit different with standard practice, at least based on our experience, is that normally what you do, you configure collectors to scrape your services. In this case, our services are pushing to the collector. So why that? No sidecars. You don't have the problem of monitoring the monitor. You don't have the problem to decide how much compute you need to allocate for the sidecar. And you have one single point of entry to control everything, which looked easier to us at the scale we were. And again, the telemetry collector then pushes through a private link, again, back to our observability vendor, which then holds everything. You have logs, you have metrics, and you have traces if you're using it. All right, where next? We want more. We want more, and we are still growing, but right now we're at a certain scale where we cannot afford anymore to just grow without thinking. So we need to adopt a sustainable growth approach. There is a lot of appetite in the market and also by extrapolation in the firm to leverage hardware accelerators, GPUs, but not only GPUs. As you might know, when you use Fargate, you are limited to 120 gigs as the top memory level you can choose. Some applications on our side require more than that, and so we are looking at alternatives. And the alternative, spoiler alert, is we are already testing and looking at managed instances, which looks really like the sweet spot where we can adopt all these elements and make our business grow and our deployment grow. Orthogonally to this, we want to keep the resiliency posture we already have. We increased it, going multi-account, and now we are starting to think to go multi-region. Because right now all the accounts were were initialized in a single region. So we started to think how to do that and take the unit I already discussed, the VPC unit with all the accounts, take it and move it into another region, have a multi-region deployment, which will give us advantages on flexibility for compute, but also resiliency, a high resiliency posture. And that was it for me. Thank you for your attention, and back to Alex. Thank you very much.